last unit in this chapter, lesson 7-9, special products of binomials. You are going to need your Know It Note page, which is page 107, and we probably can squeeze most of the things on this page. So let's get started here. We're going to start with a little bit of theory. So let's imagine we've got this square here with sides of length a plus b, and you don't have to write this down, just watch. And if we break this then into its two parts, kind of like with algebra tiles is a good way to imagine it, that we would have a plus b here across the top, and we'd have a plus b down here along the side. And when we multiply, just like we did with the rectangular grid before, for multiplying binomials times trinomials, or think about it like algebra tiles, when we multiply the a times a part, we would get a squared. And we multiplied a times b, we would get ab. And b times a is still ab. And then that last little part, b times b, would be b squared. So when you add that all up, you end up with a squared plus 1ab and another ab plus b squared. And that then simplifies to be a squared plus 2ab plus b squared. So now if you think about what that's coming from, which is a plus b times a plus b, or a plus b squared, right? We square the a, we square the b, that gives us the first part, and the last part, and then the middle part comes from doubling the product of a and b. Okay, so excuse me, that gives you a little bit of a shortcut instead of writing it out and foiling it. If you don't like the shortcut, then it's not a big deal. You can continue multiplying it out. So what I want you to write down here is the FOIL part, and you can probably write this down in the box near the bottom where it says a plus b squared on the left side near the bottom there, and FOIL it out, and then write what it equals when it's all through, which is a squared plus 2ab plus b squared. And this is called a perfect square trinomial. That's going to be really important in the next chapter. And that's what you get when you square a binomial, a perfect square trinomial. Okay. So remember the a squared, it's like we square the front one, we square the back one, and then for the middle, we get double the product. Double the product. We're going to try a couple. Okay. X plus 3 squared. You can write this down there near with a 107, or actually I don't think we're going to write anything in the blue outline box, so you could divide that into 3 sections and put your examples up there. That's probably the best spot. So if you're not sure, you can write it out twice and FOIL. But if you're feeling like you want to try the shortcut, which you should, because that's really what this lesson's about, is trying the shortcuts, even if then later you end up going back to foiling, try the shortcut. We square the first term. We square the last term. So x gets squared, 3 gets squared. In the middle, if it's plus in the middle of the binomial, it's plus and plus in the trinomial. We take the product of these and we double it. So that's 2 times the product is 3x gives us 6x. X squared plus 6x plus 9. Pause the video and try the next one yourself. Now that you're back, let's take a look at it with the shortcut. First term squared, 16s squared, plus. Last term squared, 9t squared. Middle term, 4s times 3t, doubled. So that's 12st doubled makes 24st. Hopefully you're with me so far. Remember, if you don't like it, it's okay, because you can just FOIL it. Write the two things next to each other, FOIL away. Okay. This also works with minus, okay, for a minus b all squared. If we FOIL it out, we would get a squared minus ab plus b squared Notice this part, this plus b squared. This is usually the part that trips people up. The only thing that's subtracted is the doubling of the two terms. So minus 2ab, but still plus b squared because both of those were negative. This is also a perfect square trinomial. You should make sure you write down the result of the perfect square trinomial down there, right above where it says page 107 in that little box, that little rectangle there. Let's try a few of these. X minus 6 squared. We square the first term. We square the last term, and it's added because it's negative 6 times negative 6. For the middle, it's subtracted. We take the product of the two, 6 and x, and we double it, minus 12x. And remember, you'll get exactly the same thing if you write it out and FOIL it. This is just a shortcut. You hate it? Skip it. Well, I mean, write the stuff down. But on the test, you don't have to use the shortcut. You can use the long cut. Pause the video and try 4m minus 10 all squared. Happy to have you back. Let's try it. 4m squared would be 16m squared. Both 4 and the m are squared. Minus 10 gives us plus 100 at the end. And in the middle, it's minus. And we make the product, so 4m times 10 doubled. So that's 40m times 2 makes 80m. 16m squared minus 80m plus 100. Okay. Let's take a quick look at some algebra tiles. Just watch, don't have to write anything down. We're multiplying x plus 2 times x minus 2 here. Let's fill in our parts of the algebra tiles. So we have x times x is x squared. X times 1 makes x. And again, it makes x. And then we have x times negative 1 makes negative x. And negative x. And 1 times negative 1 is negative 1. And again, negative 1. And again, negative 1. And again, negative 1. And now let's look at what we have here. So we have x squared. And we have some x's, except we have some 0 pairs. So an x and an x cancel out, and an x and an x cancel out. So all I'm really left with now is x squared minus 4. So think about what's happening there. When you FOIL it, the negative 2x's and the positive 2x's are canceling out. When you multiply two binomials that are exactly the same, except that one is added and one is subtracted, that's the only time you're going to get pretty much, not completely. There are a few other times, but mostly that's when you're going to get 2 terms in the answer instead of 3. Almost all the time when you multiply 2 other binomials together, you're going to get 3 terms. Every so often you might find one where things cancel out, but not very often. But when you multiply the addition and the subtraction of pretty much the same binomial, the middle terms will drop out. This is good to memorize, but at the same time, if you FOIL it, it works out and they cancel out. You don't have to memorize the shortcut. It's just handy. Woo! Going back in time, here we go. In the bottom box down there on the bottom right hand side by page 107, you're going to write down the result of a plus b times a minus b, which is a squared minus b squared. This is called a difference of 2 squares, and they have that nicely labeled for you. Difference of 2 squares. Pretty obvious why it's called that. Let's try a couple. These ones feel so fast and easy if you're using the shortcut because you recognize that the O and the I of the FOIL are going to cancel out. So all you have to do is the F, which is x squared, and the L, which is the last, and you're done. Right? Because remember, the other parts would have been plus 4x and minus 4x, and those canceled out. You try the next one. P squared plus 8q times p squared minus 8q. And you should get, pause it if you're not done yet, p squared squared, use those rules, is p to the 4th power minus 64q squared. We don't get addition on these problems as the answer, always subtraction. Difference of two squares, not the sum of two squares. How about one more? Woo! Jeez, what is up with this computer today? Here we go. 10 plus b times 10 minus b. Pause it, write down your answer, come back. You're back. You should have gotten 10 squared is 100 minus b times b is b squared. Done. Let's look at a couple word problems. Maybe just one. I don't know. We'll see. Write a polynomial that represents the area of the yard around the pool shown below. So we're looking for, let's get a highlighter. We're looking for this space between the big rectangle and the little rectangle, and that's going to be a subtraction problem. So we need to multiply to find the area of the yard, and we need to find the area of the pool, and then we can subtract to find the answer, which will be the area around the pool. Always make a plan first. With words, it's really helpful. So the area of the yard, it's a square with dimensions x plus 5 and x plus 5. So that's x plus 5 squared, otherwise known as perfect square trinomial. X squared plus 25 at the end, multiply the two inner ones. 5x doubled makes 10x. And the area of the pool is x plus 2 times x minus 2, which is a difference of squares. That multiplies out to be x squared minus 4. And now we're going to subtract these. So minus the whole thing, okay, means the x squared becomes negative and the 4 becomes positive. X squared plus negative x squared is nothing. 10x doesn't have anything to subtract it, so that's just 10x. 25 plus 4, not minus 4, makes 29. So the area around the pool is 10x plus 29. So if I know what x is now, right, let's say it's 10. Right now I can find the area around the pool. It would be 129. And if you go through and you do it the long way, if x is 10, I have 15 times 15 is 225. And 10 plus 2 is 12. And 10 minus 2 is 8. So that's 96. Right, and I do 225 minus 96. Right, I get 15 minus 6 is 9. 11 minus 9 is 2, and 1 minus nothing is 129. So it's just a shorter way of getting that final answer. And I'm pretty sure we're going to stop there, leave ourselves one more word problem for tomorrow, and some extra examples, and we will be good to go. If you didn't get everything written down, this might be a nice thing to look at just so you see those one more time. That should be what's in your notes at the bottom of page 107 in that nice little chart there. You should have all of those little formulas to go back and look at later. That's it, chapter 7. It was a long one.